Hi, my name is Tim Nash. I'm a principal software consultant at EG, and this session is on artificial intelligence and machine learning. So this was a result of a seminar that we did a few weeks ago. We thought we'd do some deep dives down on particular subjects, and this was one that was particularly of interest to people. So this is quite a broad sort of high level presentation. I'm going to go into a little bit of depth on a few things, but artificial intelligence and machine learning is a huge area. People do PhDs on it, so I can't possibly hope to cover that in sort of 15 minutes, but I'll have a go. So let's start with a definition. This always helps. So what is artificial intelligence and machine learning? So in the 1950s, the fathers of the field were Minsky and McCarthy, and they described artificial intelligence as any task performed by a machine that would have previously been considered to require human intelligence. So using that definition, we could apply it to lots of different things. So perhaps a more modern definition is a bit more specific. And here's a definition from Francois Chollet, who is an AI researcher at Google and has written a few books on this subject and is sort of considered an expert in his field. And he says, intelligence is not a skill itself. It's not what you can do. It's how well and how efficiently you can learn new things. So that's more focusing on learning skills, but not the skills themselves. So at a very high level, artificial intelligence can be split into two types, narrow AI and general AI. So narrow AI is what we see all around us in computers today. These are intelligent systems that have been taught or have learned how to carry out specific tasks without being explicitly programmed how to do so. The other type is general AI, and it's very different. This is the type of adaptable intelligence that we see in humans. This is the AI that we see in movies, I think kind of Skynet in Terminator. And this is not yet a reality. It's still very much science fiction at the moment, and we're still waiting for it. And there's a lot of speculation about when it might actually become a reality, but most people seem to think that sometime in the next century this will come along. So I said that AI is all around us. AI is not the future, it's the present. And it's been around for some time. We just don't see it. So some examples are if you've used Amazon Alexa, you're using AI. Amazon Alexa uses AI to take speech and transform it into text and then work out what you're trying to ask it to do. It then tries to perform that task and then responds back to you using text to speech. That's all uses of AI. Netflix is another example. They use AI to make film recommendations and also to help it choose which films it thinks its customers will watch, which films are going to be popular. And it's using that to great effect at the moment with producing its own content because it has a really deep knowledge of its customers and the sort of films that they like to watch. And therefore it can invest in the films that are going to be popular, thus taking out a lot of the kind of financial risks that they might incur with commissioning a new film. And a third example would be Tesla. They're using AI to create self-driving vehicles, and they're producing their own chips, which do this because of the amount of compute power. So that's Tesla Autopilot. So just three examples of how AI is actually all around us today. It's not the future. It's very much the present. So going a bit deeper, artificial intelligence and machine learning are related in this way. You've got artificial intelligence, which is the sort of the general field. Then you've got so a definition of that would be a program that can sense, reason, act, and adapt to mimic human behavior. So then within artificial intelligence, you have machine learning. So these are algorithms with the ability to learn without being explicitly programmed, and their performance improves as they're exposed to more data over time. Examples of this technology would be learning to play chess, for example, recommending your next Netflix show that you might be interested in, or identifying spam email. And then a subset of machine learning is deep learning. So deep learning really looks to mimic how the human brain works with neurons that are mathematically modeled to mimic how a neuron in the brain works. And the word deep comes from the fact that the neural network that is created can have multiple layers. These are really useful for more complex tasks, such as image, audio, or video classification. So if we look at machine learning, there are different types of machine learning, depending on what the problem is that you want to solve. So if we look at the first one, supervised learning, this would be a class of problem that involves using a model to learn how to map between different input examples and a target variable. So, for example, we want to teach a system how to distinguish pictures of cats from pictures of dogs. You would help it to teach it what a picture of a cat looked like, and you do that by giving it lots of pictures of a cat and saying this is a cat and this is a cat and this is a cat. Then you would give it pictures of a dog and you would say this is a dog, this is a dog, and this is a dog, and eventually it would be able to tell the difference between those. So that would be an example of a classification where you're looking to label something. Is it a cat, or is it a dog, or is it neither? The other type would be regression, and this is quite similar, but instead of giving a label, you're asking it to predict a kind of a numerical label, so something like a house price valuation. So then you've got unsupervised learning. This describes a class of problem for describing or extracting relationships in data. So this would be, for example, clustering. So that's finding groups within the data. An example of that would be in the medical field. You might be able to identify cancer cells within patients based on scan results. And then there's dimensionality reduction, which is finding a kind of a smaller set of variables that might capture the essential variations or patterns within an observable variable. So that's a lot of kind of words. An example of that would be email classification, where you've got lots and lots of variables and you want to know kind of what are the most important things to classify into different groups. And then finally, there's reinforcement learning. So this is more kind of goal orientated. So great examples of that are gaming, for example. There is an obvious goal of winning the game, and therefore you can use that to create a feedback. So gaming is an obvious type there, so might be teaching it to play chess and which moves are good and which moves are bad. Finance is another example. Obviously sort of increased profits might be your target, and therefore the feedback is if you're making more profits, then that's good, and the opposite, less profits are bad, and therefore the model can learn what's good or bad. And robotic navigation is another example. So getting from A to B, what's the most efficient way of doing that? Yeah, so different types of learning there. So how can Azure help? Interestingly, just before I was preparing this presentation, I saw a tweet from Francois Jolet, who I mentioned earlier, and he said that the hardest thing in machine learning is to find out how to productively leverage it in your product. And the second hardest thing is to collect and annotate the right data set. Building and training models is relatively straightforward by comparison. So Azure can help you by providing a lot of the tools in order to leverage these technologies within your business. Some of them will be fairly easy and some of them will be more complex. So just to list a few of them, there is Azure Cognitive Services. So this is a comprehensive family of AI services and cognitive APIs that you can that help you to build intelligent apps. So this might be anomaly detection. It could be content moderation. So moderating people's comments within your application or website, natural language processing, speech to text and text to speech, computer vision or face recognition. These are all available as APIs that you can call to add these services into your apps. Another type is Azure Bot Services. So this could be creating customer service kind of virtual assistants that you can use to connect your customers' questions with the answers, or perhaps pre-filter on help desks so that people can describe their problem and be referred to the right department. A third type is Azure Cognitive Search. So this is AI-powered cloud search services for mobile and web app development. Then you get on to Azure Machine Learning, which I'll go into a little more detail in a minute. So this is enterprise-grade learning service for building and deploying models faster. I'll explain more in a little bit. And then finally, there's Azure Databricks. So this is fast and easy collaborative Azure Spark-based analysis services. So this is a managed Spark environment that supports Python, Scala, R, Java, and SQL, as well as data science frameworks and libraries, including TensorFlow, PyTorch, and scikit-learn. So those are all quite advanced features that data scientists might use with exploring data. But by using Azure, you can have a managed environment that takes away the overhead of having to create those environments for yourself. So let's talk about Azure Machine Learning. So Azure Machine Learning can be used for any kind of machine learning, so all the different types that I mentioned earlier. And you can use Python or R code using the SDKs, or indeed you can use a no-code or low-code solution using the Studio. You can start training models on your local machine, and then once your model is created, you can then scale it out to the cloud and use an almost unlimited amount of computer power that Azure Machine Learning can provide for you. So here's an example of how Azure Machine Learning can work. In this example, it's a basic drag and drop interface, so it doesn't involve you having to learn any code. You can just take the building components that are already in the Studio and apply them in order to create your model and your workflow, and also collaborate with colleagues. So the pricing on Azure Machine Learning is a free service. You simply pay for the compute services that you use, plus any other machine learning services, any Azure services that are part of the solution. So things like Azure Key Vault or Kubernetes, that sort of thing. Most services have a free tier to get you started. So that's really useful for initial development and proof of concept. And also services generally have a volume-based pricing, so you pay for how much you use i.e. kind of how many calls you're making to a particular API, which again is one of the real benefits of cloud-based technology. You don't have to have that initial investment in creating your own infrastructure. You can start small and then leverage the cloud to provide more resources and scale up as your business grows. Well, thank you very much for listening. I hope that's been useful, and if you'd like to talk to us further about any of the items that I've mentioned in this presentation, or indeed any data or software development, please contact us at sales@ijyi.com or ring us on 01473 558748. Thank you.